Alright, so we are going to be talking now about heterogeneous equilibria. We've been talking about homogeneous equilibria, and homogeneous is when everything is in the same phase. So that's all gas or it's all liquid. Solid doesn't really work out because the molecules aren't moving that much, and so we don't usually see reactions with when you put two rocks together. It doesn't all of a sudden boom into a reaction, right? So that's what we have been talking about. Put everything in the same phase and look at just how are they reacting. Heterogeneous then I left my little stylus at home, so I'm writing with my finger today. You probably all tell. Is when I have two different phases. And before we can really talk about this, we have to think about some other things. Number one, we are talking about concentration. Right, which is the amount of solute, or the amount of stuff, in a given volume. Okay, if it is a pure substance, right, then let's say I have a rock. That's a rock, and it is pure iron, and it has a density. Alright, so the density of iron is 6.98 grams per cubic centimeter. Well, let's say I react this with an acid and I eat away that much. Okay, and this is now gone. Well, my concentration didn't change. My density of iron didn't change. The amount did, right? The amount of my stuff, but my volume also changed. So overall, the concentration didn't change. Well, and that's what we're looking at when we're talking about equilibrium constants, right? Is the concentration of my products over the concentration of my reactants. So if I have a pure solid, well, if I have a solid of any kind or a pure liquid, no, pure solid. It's pure solid. I'm sitting here thinking through my head. If you have a mixture of a solid, then the density can change. So yeah, if you have a pure solid or a pure liquid, it isn't part of the equilibrium. Equilibrium expression. It is part of the equilibrium. You still have to have it there, but you do not write it into your equilibrium expression. So if I have that H2 plus O2 goes to make H2O, what we would originally want to write is that K is equal, and this is C, concentration. Again, C isn't the big deal here. You see the big K, you immediately go to your products over reactants. But you would go Alright, so that's what we would want to, but then we look at this and we say, oh, this is a liquid, a pure liquid, water being a pure liquid, and so I can get rid of that. So it actually goes to that. Alright, so it's a simplification step. If you see pure substances, pure liquids, pure solids, you do not have to write them into your equilibrium and use them because their densities don't change. And so the concentration of whatever is left, whether you're gaining or losing, stays the same.